let's work some inelastic collision problems. Remember, in an inelastic collision, things stick together. So if I have one block that's moving at a velocity, let's say this way, and it has a mass of m1, and it's approaching another block of m2, and let's just say v2 is going that way. And say that they're real sticky. There's putty between them. There's going to be a collision, and remember this double arrow always means collision. Alright, so something has happened, there's been an impact. In an inelastic collision, they're always going to stick together. So you're going to have m1 stuck to m2. And we're going to say they move off with some velocity v prime. That prime always means after collision. Now, let's see how we read these problems. Remember, momentum is mass times velocity. So to read these problems, we literally read straight down. So this becomes m1v1. So that's the momentum of the first block. And we have another block here, so we're going to add to that the momentum of the second block, which is m2v2. Now, I'm not going to worry about this sign right here, although we know right is positive and left is negative. Now, this big arrow here always means equals. Now, let's look at these two. They're stuck together. So when I read this straight down, I'm going to have m1 plus m2 times my final velocity. So, on an inelastic collision, this is always the equation you're going to need to come up with. You're going to need to draw a picture that looks something like this, where you need to make sure on every one you need to identify, okay, m1, m2, the velocity of 1, the velocity of 2, and then the final velocity. So this is final velocity of both of them. Let's do a couple of problems. A railroad diesel engine has 4 times the mass of a flat car. If a diesel coasts at 5 kilometers per hour into a flat car that is initially at rest, how fast did the two coast once coupled together? Okay, guys, draw a picture and let's label it as carefully as we can. A railroad diesel engine. So this is a diesel engine, and it has, this is the engine. Go ahead and label it. E-N-G-I-N-E. Can't spell today. And it's rolling into a flat car. I'm just going to call this FC. There's going to be an impact, and then they get stuck together. Now my picture's kind of in the way. So this is the engine, and this is a flat car. We're going to call the engine M1 and the flat car M2. Now, a railroad diesel engine has 4 times the mass of a flat car. So I'm going to come down here. So the mass of the engine, or mass 1, has 4 times the mass of the flat car. Now the diesel engine starts, so this is V1 at 5 kilometers per hour. So V1 is 5 kilometers per hour. And the flat car is initially at rest. Oh, I like that. So V2 is 0. Now after the collision, I know they're going to go off at some final velocity. And we want to find that final velocity. Let's read this equation. I'm going to have M1 times V1, M1, V1, plus, because it's on the same side, M2, V2. Now, I like this because V2 is 0, so I'm going to go and cross that out. Equals, so put my equal sign. This is going to be M1 plus M2 times my final velocity, and that's what I'm looking for. So to get my final velocity, I'm going to divide both sides through by M1 plus M2. leave that alone because it's 0. So the velocity, they're going to go off together, is equal to the mass of the engine times the initial velocity of the engine divided by the sum of the masses. So the mass of the engine, let's see, that's 4 times m2. I'm going to go on and put that in there. 4m2 times v1. v1 is 5 divided by m1 is 4m2 plus m2. So this is going to be 4 times m2, and I'm leaving it this way for a reason, times 5 divided by 4 plus 1 is 5m2. If I don't give you the masses, you don't really need them. Things will cancel. Look what happens. m2 goes away. 5 cancels out as well. So I'm left with an answer of 4 kilometers per hour. And there's my answer. Now, suppose I have a goalie and hockey puck. Let's see. I have a .015 hockey puck moving at 48 meters per second. So what does my hockey puck look like? I'm going to make it this way. I'm going to call it M1. And it's moving with some initial velocity. So M1 is 0.105 kilograms. And it's moving with a velocity of 48 meters per second. And it is caught, so we're talking inelastic collision, by a 70 kilogram goalie at rest. So here's my goalie. I'm going to make him a box. He's M2, and his initial velocity is 0. So M2 is 75 kilograms, and V2 is 0. There's a collision. Now the understanding is the goalie catches the hockey puck, so we're going to put these kind of together, and they move off with some final velocity. So my final mass is going to be M1 plus M2, and I'm looking for V prime. This is another way to set it up. You can actually set these up in a chart so that you can actually read the chart. Do whatever is easiest for you. Now we're going to read our momentum. Read it straight down. M1 V1. M1 V1. Having trouble writing tonight. M1 times V1 plus, it's on the same side of the equation, M2 V2 equals, my arrows always means equals. Now they're stuck together, so it's going to be M1 plus M2 times V prime. Oh, let's see. I know this is 0, so I'm going to mark it off. Now I'm solving for V prime, so I want it by itself, so I'm going to divide both sides by M1 plus M2. This factor that is being multiplied here by V prime. So I have to do it to both sides. Remember, that's a cookie theory. What you do to one side, you have to do to the other. That's 0, so I'm going to leave it be. So V prime is M1 V1 divided by M1 plus M2. Now plug in our numbers. This time we have real numbers. So this is 0.105 times, what's my initial velocity? 48. Divided by M1, which is 0.105, plus 75. Now, don't ever be ashamed of multiplying things out. 0.105 times 48 is equal to 5.04. And we're going to divide that by, let's see, 0.105 plus 75, well, that's 75.01. So, I'm going to put in my calculator, 5.04 divided by 75.01, and I get an answer of 0.671 meters per second. box my answer. Always show as much algebra as you need to show. Now, in this problem, I have a 35 kilogram bullet hitting a 5 kilogram stationary object. So I have M1 and M2. The bullet embeds itself. All embeds means is it gets stuck inside, just like this here. So this is stuck inside. You gotta learn to read physics. The block and the bullet move together at V prime is 8.6 meters per second. What was the original velocity of the bullet? So we're looking for V1. Well, this is a little unusual. Go ahead and make your chart up. Organize your data. So, M1 is the bullet. And go on a right bullet here. Make yourself organized. And this is your block. Okay, the bullet is M1, and the bullet is 0.35 kilograms. That's a seriously sized bullet, let me tell you. And we're looking for V1. We don't know it. The block has a mass of 5 kilograms. And it was originally stationary. Stationary just means the velocity is 0. So V2 before the collision is 0. After collision, we have them together. So M is going to be M1 plus M2. I'm going to go ahead and do the calculation because I can. This is 5 plus 0.35 or 5.35 kilograms. And I know the final velocity, it tells me it moves off at 8.6. Alright, now, let's write our conservation of momentum. M1 V1. M1 V1 plus M2 V2 equals M1 plus M2 times V prime. Now, let's see, what equals 0? What can we get rid of? I know V2 is 0, so I'm going to mark that out. And in this case, I'm looking for V1. So, to find V1, I divide through both sides by M1. So, V1 is M1 plus M2 divided by M1 times V prime. Now, V prime can be actually in the numerator, or you can make this fraction here. Remember, it doesn't matter what order you multiply as long as you divide in the correct order. 2 times 3 is equal to 3 times 2. So let me plug in my numbers. M1 is 0.35 plus 5, and I could have just pulled that over here, divided by M1, which is 0.35, times 8.6 meters per second. So I get, when I do this, this is 5.35 times 8.6. Oh, I'm running out of room. Divided by 0.35. If I'm very careful, I get a velocity of 131.46 meters per second. Now, does this make sense? The bullet is very small. It hits a big block, and they go off at 8.6. So the bullet should be traveling much faster than the combination. So yes, it does make sense. Always use a common sense check. Now, suppose I have a 3,000 kilogram truck. So here, M1 is 3,000 kilograms. It's traveling east. It has a speed of 5 kilometers per hour. And it collides head-on with a 1,000 kilogram car. So this is M2. So M2 is 1,000. This is not good for a car, let me tell you. Moving west with a speed of 10 kilometers per hour. So V2 is negative 10 kilometers per hour. Now this negative sign is because it's going west. You remember, right is positive, left or west is negative. We have our collision. They stick together. Oh, not good news for the car. And they move with the same velocity. We want to see how fast are they going. Basically, how fast is this truck dragging this happy car? Not very happy. Let's see. What is my final mass going to be? It's going to be m1 plus m2, and we're looking for v prime. Okay, let's read straight down. m1 v... do I keep doing that? Let's see. Erase it. It's always okay to erase. m1 v1 plus m2 v2. This is always equals m1 plus m2 times the final velocity. Okay, always read straight down from your diagram. Well, in this case, this doesn't equal 0. Well, we're going to go on and be careful. I'm going to divide both sides through by the sum of the masses. Can we go on and find out what that is? How about that? m1 plus m2 is 3,000 plus 1,000 or 4,000 kilograms. It's always okay to go on and do any extra calculations up above. So, v prime is equal to, I'm going to divide both sides through by m1 plus m2. Let me show you. It's got to divide the whole thing. Let me erase this so I can be a little bit more clear. Okay? You've got to divide both elements here by m1 plus m2. Let's rewrite this. I'm looking for v prime, and it's always easier to go on and get v prime all by itself. Oh, someone to switch here for me. Okay. I am not able to get this off the eraser. Golly. That's just funny. Okay. So, v prime is equal to m1 v1 plus m2 v2 divided by m1 plus m2. Oh, goodness gracious. Now, m1 is 3,000 times v1, which is 5, plus m2 is 1,000 divided by v2, which is negative 10. You have to leave that negative sign in. Divided by m1 plus m2. We can write this in, or we can go on and plug in what we already know. And I'm tired, so let's just put in the 4,000. Go ahead and multiply this out. 3,000 times 5 is 15,000. And this negative sign is going to come out front, so it's going to be minus 1,000 times 10 is 10,000. And this is going to be divided by 4,000. So let's see, 15,000 minus 10,000 is 5,000 divided by 4,000. Always do any addition or subtraction in your numerator or denominator before you do any division. So I wind up with 1.25 kilometers per hour. So basically, the poor little car is going to be pushed back at 1.5 kilometers per hour. Head-ons are not good with trucks, let me tell you. Now, oh goodness, suppose we have a 75 kilogram fullback. That's this guy right here. So this is, we're going to call him MF because that's how I've labeled it. Is moving east with a speed of 8 meters per second. So the velocity of my fullback is 8 meters per second. And he collides head-on with a lineman who has 100 kilograms. And he's moving at 4 meters per second. But remember, he's going left, so this is going to be negative. They collide in a stick. Oh, that's not good. And they move with the same velocity after the collision. How fast are they moving? And what direction? Okay. So, let's see. The mass of the fullback is 75 kilograms. And the initial velocity of the fullback is 8 meters per second. The mass of the lineman, let's see, he's 100 kilograms. And his velocity is negative 4 meters per second, and it's negative because he's moving backwards. And this, let's see, we have our collision, and then the mass total is going to be the mass of the fullback plus the mass of the lineman. And let's figure out what that is. 75 plus 100 is 175 kilograms. And we're looking for our final velocity. This is how I want you to write your givens for these. Now, let's write our conservation of momentum law. Mass times velocity, mass of the fullback times velocity of the fullback, plus mass of the lineman, velocity of the lineman. This always means equals the mass total times v prime. Now I'm going to write it this way. We want to find their final velocity. So now what we've got to do is solve for final velocity. Circle it. We're multiplying by the total mass, so we have to divide by the total mass. And we have to divide the entire right side by the total mass. I'm going to reverse my signs here. V prime is mass final, velocity final, plus mass of the lineman, velocity of the lineman, divided by the total mass. Now I could have written this as the mass of the fullback plus mass of the lineman. I'm showing you how to use the steps up here in a slightly different order. So the mass of the fullback is 75 kilograms. The velocity of the fullback is 8 meters per second. Plus the mass of the lineman is 100 kilograms. The velocity of the lineman is negative 4 meters per second. And this has to equal my total mass, 175, times, got carried away there. Wrong equation. Okay, and this has to be divided by my total mass, or 175 kilograms. Go on and multiply this out. 75 times 8 is 600. Minus, because this negative sign comes out front, minus 400 divided by 175. 600 minus 400 is 200 divided by 175. And when I put this in, I get 1.14 meters per second. Because my answer is positive, I know he must be moving